The nice thing about AI is that when it looks at a data set, it looks at all the strategies, all potential outcomes. It goes beyond human bias because as humans, we kind of know what's going to work and what's not going to work, and we put our efforts in what we think is going to work. But AI can free us from that and look at all of these things that we thought were not possible.
Hello, I'm Bruce Berman, the host of Understanding IP Matters, a podcast series that looks at the impact of intellectual property rights on people and business. Season 3 spotlights such topics as artificial intelligence, IP licensing, and TikTok as a learning tool. Enjoy the episode. Artificial intelligence is not new. It was developed in the 1980s by researchers in an area of Cambridge, Massachusetts, which became known as AI Alley. Most people believe AI today is just generative AI, large learning models that perform natural language processing with written prompts, such as ChatGPT. But AI is much more than that. It is used today by businesses to analyze data and increase productivity, and by machines like robots to learn how to operate more like humans. Understanding IP Matters is pleased to have as its guest today two leading exponents of AI. One, an entrepreneur who was a former INDYCAR racing strategist, and the other, an investor who funds AI startups in the life sciences. Alex Kastrunas is the founder and CEO of Why of AI, a book author and a professor of AI at Northwestern University's Kellogg and McCormick MBAI program. He has over 2 decades of experience advising startups to Fortune 500 companies on using data, analytics, and AI models to drive business growth and customer success. Alex is a former INDYCAR engineer, race strategist, and data scientist. His experience applying analytics to make smarter, data-driven decisions in racing now helps businesses gain a competitive advantage in their industry. Armando Poker is co-founder and general partner at Tensility Venture Partners, whose investments include artificial intelligence, digital health, cybersecurity, and fintech. Previously, he was a general partner at Apex Venture Partners with an investment focus on enterprise hardware, software, and clean tech. Armando served as a management consultant with Booz Allen Hamilton, where he worked with technology clients. He has served on the boards of 6 companies, all of which have exited positively through acquisition. Gentlemen, welcome to Understanding IP Matters. Today, we are going to look at not only why artificial intelligence matters, but how it impacts businesses, creators, and the public. In the end, it's all about data, isn't it? And there is more of it than ever. As a data scientist, Alex, you see firsthand how businesses and creators struggle with the volume of data they must contend with. What makes artificial intelligence so well suited for the task?
As you said, right, enterprises today are dealing with massive amounts of data, and they have data across the board. So, you have your marketing data, your operations data, your sales data, your ERPs, CRMs, and so on. And so there's a ton of data. And one of the challenges with dealing with this data, and data, by the way, encodes really valuable things, right? They say data is gold. And so if you think of data encodes patterns, it encodes relationships and correlations, and all sorts of other types of things that you can gain very valuable insights from. The issue is when you think of, let's say, business intelligence, right, which has been very popular for quite a number of years. And so a lot of companies have focused on building sort of their back end in terms of looking at data lakes and data warehouses and all these sort of collecting data in such a way that you can integrate it so that you can perform efficient analytics on it. And part of that is building these like BI tools and dashboards. But the issue is at the end of the day, even if you have BI tools and you pull up a bunch of charts and graphs and so on and dashboards, you still have someone interpreting the data and trying to understand, okay, well, what is this metric or what is this chart or, line mean? And how do I interpret it and then make an actual decision for the company? And you could have 10 different people interpret the same data 10 different ways. Even if you created a dashboard with 300 charts on it, you still couldn't understand all of what your data is encoding for you, right? So AI actually helps to understand this massive data and detect these patterns in ways that you can make predictions.
Armando, as an investor, what attracts you to AI today?
There's many things. AI, as Alex mentioned, Alex described where BI was. So BI, business intelligence, is really about making predictions. And AI goes beyond that to go from being predictive to prescriptive. And so that's kind of like the next frontier. To give more depth to what Alex said. So the difference between being predictive and prescriptive is that, for example, we can predict the weather tomorrow. So let's say there's an app that says, hey, tomorrow it's going to rain. So that's predictive. That's great. But prescriptive says that tomorrow it's going to rain in Chicago, where we are, but I happen to be in New York and it's not going to rain. So because the system knows that I'm in New York, I don't have to bring an umbrella. So even though it's predictive of where I live, it's smart enough to know that the prescription is don't bring that umbrella because you're not there. So that's that next level of intelligence where that is very, very important about not only taking those graphs that Alex described, the 300 graphs, which is great, but it forces a human to make a decision and interpret that. But then the system will be able to make a recommendation and say, okay, this is what you should do. Or here's an idea, or here's 3 ideas, or here's any number of ideas of things or number of possibilities. So what we see within AI is the ability, for example, to be able to look at those things that humans have a hard time looking at, and being able to look at the totality of potential answers. The nice thing about AI is that when it looks at a data set, it looks at all the strategies, all potential outcomes. It goes beyond human bias, because as humans, we kind of know what's going to work and what's not going to work, and we put our efforts in what we think is going to work. But AI can free us from that and look at all of these things that we thought were not possible.
Now, data drives value, but it is not necessarily or easily protected under intellectual property rights. So you have this data, this valuable asset, if you will, but the techniques for analyzing data may be protectable.
We don't think that the techniques for analyzing the data are necessarily protectable. When we look at the company, we look at both the data, and at least for an investment, for the proprietary nature of that investment, and then kind of like the application, and then something that Alex and I were talking about, the accuracy of that application for AI, to make AI valuable. But the actual methods for analyzing the data generally tend to be open source algorithms. These are algorithms that are published in papers. These are algorithms that come through either with standard libraries, either like Python has many, many libraries. There's many other similar languages. So the analysis method is not generally protectable, and you don't want it to be, because you want to be in a position where you want to be able to leapfrog to the latest method, the latest technique, especially as it comes out of universities or out of common knowledge like open source.
So what is proprietary within regard to an investment? You're investing in this company and they don't have proprietary techniques, and the data is open and the source is open in terms of the platform. So what are you protecting?
So not all data is open. All data is maybe available, but you can create your own data sets. For example, if you are a researcher, let's say in physical sciences, there's a term used in AI called ground truth, which means creating a data set that is validated. And it could be validated through experimentation. For example, and the experimentation is that you physically took that data yourself, either through a mass spectroscopy method, or if you looked at it you were looking at chemical reactions, or you were looking at biological reactions. All of those methods of data gathering are ways of creating unique data sets.
Alex, what do you see with regard to proprietariness? Can AI or aspects of AI be protected under IP?
Armando mentioned some of the really important things, which is just that a lot of these tools are open source and so on. So it depends what you're using. I mean, not every company has AI researchers, let's say, like PhD level AI researchers on staff that are literally writing the papers that Armando talked about. Those people are actually experimenting, trying to find new ways to create new algorithms to push the field of artificial intelligence and machine learning forward. They're the people that came out with like the very famous "Attention is all you need" paper, which sort of launched transformers to the world, which now is resulting in ChatGPT and GPT. And of course, now we have text to image type models like DALL-E. So underneath things like DALL-E and Midjourney, there's these methods, one's called Clip, another's called Glide, and so on. If you're a company that is really pushing the envelope there and you're creating these new techniques and these new models and these new algorithms, and you're really pioneering the way, then potentially, you could patent those things. You could consider them to be very proprietary and consider them to be part of your IP portfolio. The question then becomes, are you going that route? Like an OpenAI, right, is very proprietary in that sense. And they're certainly, just like Armando mentioned, DeepMind, it's some of the largest, what I would call AI research firms, and the leaders are organizations like OpenAI, DeepMind, Anthropic, Meta. Meta is very advanced in AI and is pushing the envelope there. Google as well. And so do they keep it proprietary or do they open source it? In the case of Meta, they have Llama and models like that. They've chosen, even though they're advancing the field and they're pioneering the way, and they could have proprietary sort of methods, if you will, and algorithms, they're choosing to open source those. They choose not to, whereas other organizations don't. So it just depends.
But you have to think about it from a broader perspective. If you think about it as the AI model, the AI analysis part as being math, right? It's just, AI is not just one thing. It's like many different methods. And each one of the methods is, you have to think of it as kind of like a path of math. It's a probabilistic path. So AI is this broad set of mathematical probabilistic techniques. It doesn't behoove you to kind of hoard any particular technique, because if you do, then you cannot have that technique improved by other people. No one would consider, hey, I'm going to create a math algorithm, and then just keep it to myself, because again, it might be state of the art today, but you're not allowing other people to improve upon it. And then if you get locked into that kind of mindset of, hey, I'm going to hold on to this, then you're going to be, in 1 year or 2 years, you're going to be behind the curve and you're going to move to something else.
It's algorithms, I think, used to be to some extent patentable, but not anymore. Armando, when we spoke previously, you suggested there are three basic types of AI business model. And I think it's worth deconstructing here. Generative AI, which people know most about, large learning models based on scraped and licensed data like OpenAI's ChatGPT. These are language prompt driven. Another model is productivity oriented, that analyzes company or industry data to identify insights and achieve efficiencies previously unattainable. And finally, there's what I call machine learning, training robots and other devices to better mimic human actions. Am I missing anything?
Well, I think you have to think about it. When you think of a big enterprise, you think of, there's like probably right now 3 vectors where AI is being used in the company. Like you described, one of them is within your engineering teams. They will probably use a bunch of models with proprietary kind of data, company data being proprietary, and they can create a number of things with their own models. But then that's kind of an engineering research, and then it moves into production. But then you might have the people in marketing or people who are using the third-party API-driven kind of large language models. They would access ChatGPT through those APIs, and so that's a path. And then the other one where you describe the productivity is the AI that's coming from the big tech vendors. It comes from Microsoft. It comes from Zoom. The people were using here. It comes from Salesforce. So that AI that comes from the big tech is really around helping people become more productive and helping them do more with, the tools that they have. But you can also see another way of thinking about it, that when you think about it from IP, these are all different ways that IP may leak into your organization, right? There's a concern that IP will leak out to OpenAI through the third-party vendors. You might be concerned that you're using Google Drive as Google's looking at your models, at your data. That there's three, and then your internal people may be doing something that could potentially leak data, depending on how they construct it. So you can look at it as three places where AI is being used. You can look at it where three places where AI is potentially, there's data leakage, or three places where there's potentially IP creation. There's different ways of looking at the same thing.
I think at the end of the day, the big question that organizations need to ask themselves is whether or not they want to keep everything in a secure environment where their IP is protected, it's secure, it's using models that they control. Like maybe they have a cloud built on Amazon or AWS or GCP or Azure or whatever, and they could create what's called a VPC, which is a virtual private cloud with its own, gateway and security mechanisms, and all their data is in the back end in that cloud. And they deploy LLMs. Let's say they're creating a conversational interface on top of their data, going back to what Armando mentioned as grounded knowledge. So you have your sort of knowledge base, and you're building this conversational system on top of it, maybe even using some of the latest sort of patterns like retrieval augmented generation, or what they call RAG for short. But yeah, companies really have to make that choice if they want to have that and keep it all in-house and secure, or if they want to have the potential of sending proprietary company data to OpenAI or whoever else, where then it becomes really important for these companies to read the privacy policies essentially of these organizations. Because, I haven't read OpenAI's recently, but I know earlier when they were sort of first launching ChatGPT, it said pretty plainly that, for quality control and so on, people within the organization, like engineers at OpenAI, could read the prompts and read what's being sent to their APIs. And there could be, once the buzz hits the public and the hype, everybody's going in, oh, I could use OpenAI to send an email. Maybe they're writing in there, hey, help me write an email about this new drug that if it's a pharmaceutical company, we're using these molecules, and help me write an email to describe that to some experimentation lab that we partner with. And you just gave away the formula of the thing. Or I don't know, I'm just totally winging it here on an example, but I'm sure a lot of people right away were just sending proprietary information and data, and maybe even customer data in prompts right off the bat, because there was there's no governance in place. I think these organizations need to catch up with this stuff and sort of start putting SOPs and policies, internal policies in place, saying, hey, it's fine to use these tools if you're going to use the third-party ones, but you need to not be sending that kind of stuff. Just last thing I'll say here is, I think in the end, there's two major pressures, if you will, happening from the market, especially the enterprise market today, on these research companies and LLM creators. And that is, one, it can't hallucinate. If it hallucinates and it's not trustworthy, then it hampers adoption and people won't want to use it at the enterprise level, let's say. And then secondly, it goes back to that question of open source or having it all in-house in your own cloud and so on. If you don't have that, then there's just a lot of risk that exists, right? So I think even the proprietary companies like OpenAI, they're working on the open source versions of things and the things you could deploy in your own secure environments, because you kind of have to.
This question is maybe more directed to generative AI, but the speed of the internet and access to content make it feel like everything is free or should be. There's a great promise in AI and machine learning, but concern about transparency, privacy, misuse of rights. We touched upon some of these things. How concerned should we be?
Well, I think that we should be somewhat concerned, but we know that there's There's things that we already know. We know that there are civil rights and civil laws that are in place right now, right? You can't fraud people. You can't libel people. You can't scam people. There are a lot of things that you're not allowed to do. And so as we establish more and more governance around these AI models, which Alex referred to, and the governance is coming, we still are going to live within the construct of existing social laws. And there's starting to be more and more things about new laws being created about what can be transmitted. For example, what kind of images can be created, what images can be transmitted. And I think that, so on the one hand, at the big picture, that we're going to go into like a death spiral with AI, I'm not concerned. We've been very effective in suing people and, putting people in jail for many kinds of these kinds of crimes. However, I think that from an enterprise perspective, you should be concerned about the leakage of your data in the same way that HIPAA is a law that says you cannot disseminate, proprietary medical data. Well, we got to comply with HIPAA. We have to comply with these laws. And so what we don't have is the governance yet to be able to verify that the laws are being complied to. We have plenty of laws, and it's a question of that. And I think the other thing is just the IP leakage, the concern. That's not a law. That has been happening since the beginning of time, right? People having kind of different ways that data comes out of the organization. And then if people trade on it, for example, it's called insider trading. Well, insider trading was an example of IP leakage, right? And then somebody doing something with it that was illegal. And then eventually that it circles back.
In generative and other AI models and data sets can be a mystery. And a lot of unlicensed content gets scraped and included whether the owner likes it or not. Unlicensed is sometimes under fair use, sometimes not. It still is yet to be determined what some of the data sets are comprised of. The lack of transparency is troubling. Can anything be done to improve this?
Yeah, this one's very interesting. And obviously, or maybe it's not so obvious, but I think we're going to see a lot around the legal aspects of this, right? And probably going up to the Supreme Court in the not so distant future in terms of the copyright issue, potential copyright issues. Obviously, we're seeing the strikes that happen in Hollywood with SAG-AFTRA and everything else. It's a concern, especially for creative people that make a living creating content. It's interesting. I have various ways of thinking about this. On the one hand, what's interesting is that humans learn the same way, right? So in other words, when we go to college, we get degrees, maybe we specialize in medicine or law or something. So we read other people's textbooks that they wrote. We watch videos and we learn, about all these different things from different kinds of mediums, video, audio, podcasts, images, you name it. If we want to be a painter, we study the Renaissance and Cubism and all that stuff, and we learn from copyrighted works of other people. And then the idea is that hopefully we go off and to Armando's point about laws, we don't go copy someone else's thing verbatim and call it our own, because that would be plagiarizing something. But rather we remix, we use everything we've learned of other people's content, and we use it to create new and original and creative things that we present to the world. When we think of these models like, LLMs and ChatGPT and so on, that to your point are scraping the internet, they're using Wikipedia, they're using books, they're using scripts, you name it, podcast audio that's transcribed maybe into text and so on. Once that happens, you have this model that's also, to Armando's earlier point about it all being mathematics, that just sits there, and it's like, it could be hundreds of billions of numbers, what we call in the field parameters. And then when you put a prompt in ChatGPT or an LLM and you hit enter, all that really happens is those numbers, those parameters do mathematical operations and then spit something out, right? It's not pulling from a database. It's not, the parameters have no understanding of the script from the movie Die Hard or some painting that somebody did or whatever. It's just a bunch of numbers. And the thing, you know, hopefully is creating something new, but it doesn't understand any of that stuff. My point is it's trained like humans are trained, and it's creating in a similar way that humans create. Now, that being said, what it really in many ways comes down to is copyright laws and where they stand and whether or not they're even updated enough to handle this AI thing that's happening. And then secondly, what are the terms of use on these sites, right? Like if like a LinkedIn or well, Wikipedia is open, but other sites in their terms of use say, hey, it's not okay to scrape our data. It's not okay to use our data and this and that. And then people are out there scraping it anyway and using it. That's a different question that becomes, you know, not only becomes a copyright issue, it also becomes like a violation of terms issue and other things.
I don't think it's as much that they don't want their data to be scraped, but they want to be compensated for, sort of like the actors. You know, actors, I don't think they're against using their image, but they want to be paid.
I think you're right but you're starting to see that, right? You're starting to see, for example, like New York Times demanding they get paid for their content. But that's going to happen. And I think that as more and more of those things happen, a lot of this will kind of settle out, right? The issue is not so much that, hey, you're using my content, that I'm not getting paid. And this will all get figured out slowly, but it will be. But, you know, you saw even like last year that AI generated, diffusion model generated AI images were not copyrightable, right? So that's a clear thing, right? So that stops that. So more and more will be clear.
Initially, the internet made it difficult for content providers and creators like recording artists and authors. But, some have learned to navigate the digital environment. New technology comes out, file sharing, whatever, and we learn how to work with it and even use it to their advantage. One of the problems is that still basically there's one search engine, Google search. I mean, there are others, but let's face it, it's 90% of the traffic. Is there going to be one or two basic AI models, generative AI models? Is it going to be ChatGPT and maybe Bard, and that's it?
You have to follow the money. So if you look at the investment in generative AI, the bulk of the investment is coming from big tech companies. And the big tech companies being Microsoft, Google, Amazon, these kinds of companies are doing the biggest investment in AI startups, generative AI startups. So you look at OpenAI, all the money they've raised, most of it came from Microsoft. So, right, so there's going to be an alignment between OpenAI and Microsoft. Google has their own set. Facebook has their own set. Apple, there's probably a slot still there for Apple. Amazon has spent a lot of money investing in Anthropic. So I think that you're going to see, much like cloud, you're going to see AI services. You have three main cloud vendors right now. You're going to see main cloud AI services coming from those people. But there's going to be a lot of open source alternatives for people to do, either build things in-house using the open source products or build new things. Like there's a new thing coming, which is called small language models. So maybe you're not going to use a big one. You're going to use a small one, and you're going to tune it to your own data. And so there's a lot of things to be done, but for the bulk of the population or the bulk of users, maybe getting something from one of these big three is enough. Microsoft is going to integrate it into their product set. So that's how you're going to use their AI, right? If you use Word, you're using their AI. If you Excel or PowerPoint, that's how you're going to access it. Amazon is going to do it through AWS if you want to use those services, but that's happening now. There's a lot of ML tools, machine learning tools, or natural language processing tools that you can access through those services. So this is just another layer of add-on. But I think that you're not going to be boxed out that, hey, that's the only thing I can use, because there's going to be a new research paper that says, hey, look, Look, even like this week, yesterday, you saw that Samsung is introducing an AI-based phone, right? So those phones have like some very small language models, and so it's going to proliferate in many different ways, just like the internet.
Yeah, I don't know the answer. I think we have to wait and see how it plays out. I think it depends on, now you're even hearing people talk about should open source be regulated, because maybe open source could lead to the harmful AI as opposed to the proprietary companies have more control over it and so on. I think in the end, if open source gets ahead and takes the lead, if you will, and by the way, again, companies like Meta are open sourcing models. So there's big AI research companies behind some of this open source stuff, then no, there wouldn't necessarily be just one or two leaders. It's just like now, for example, there's a library called scikit-learn that does a lot of machine learning type stuff, not necessarily large language models or transform or even Hugging Face. So Hugging Face is the de facto transformers library, and it's open source, and pretty much everyone's using it. It is the most predominantly used transformer library out there. It's open source, and it's not owned by necessarily by any of these big sort of proprietary companies. So they're certainly out in front, but they're open source. So I don't know, it'll just depend where the winds blow, and we'll have to see how it plays out. But I do want to, if I may, just go back to one thing we were talking about earlier, where Bruce, you had said about the terms of service. You were saying it's more about people getting paid, for their work. I would say, though, actually, it's not that I don't agree. There is another nuance there, and it is IP related. That's really important. And it goes back to what we talked about earlier about proprietary data sets. If you think of LinkedIn, for example, right? LinkedIn has a very proprietary data set. They have the largest professional network database in the world, right? And if you were to go and scrape all of LinkedIn's data, basically everybody's profile and so on, and just pull it out, suck it out, and then put it in your own database, you basically replicated LinkedIn's entire backend and their whole business model, their backend, their proprietary data that no one else has, and so on. And I could pretty much guarantee LinkedIn, if that were to happen and that started coming out in some way, just like some of these images or whatever, I don't think LinkedIn would want to get necessarily paid for it, like in the sense of a creator, like an artist, as much as get paid for it in a lawsuit, because it was a major violation of their terms of service. And it's literally like there's a lot of nuances to this, and it's a really big question that it is going to play out, I think, here in the next so many years. It'll be interesting to see how it all goes.
I think the thing with LinkedIn is that they would not be considered a creator. And I think it's the creators are the people who want that's their nature, right? They create music or text or whatever, images, so that eventually they can get paid. So that you're going to have, like, you're right, there's going to be a segmentation of the creators, and then there's the people who are data service providers. The data service providers would not want their data set to be replicated, right? Because that's what they sell. That's what LinkedIn sells, right?
Although LinkedIn is a user-generated content too. There's newsletters, there's posts, there's blog articles on LinkedIn.
Yes, that's true. But like if I post something on LinkedIn, I'm free to post it anywhere else and sell it anywhere else. So in that sense, LinkedIn does not own that, right? They are a data service provider in the same sense where, like, Experience is a data service provider on people's, financial conditions, and all their transactions. But I could also, it's mine. I think that you're right. You're going to see creator kind of IP litigation. Then there's creator, data service provider information. And so they're all going to be treated differently.
I should mention before I forget to our listeners, both Armando and Alex are going to be speaking at the IP Awareness Summit in Evanston at Northwestern on March 28th. And those of you who can make it, I think you'll find really interesting discussions going on about artificial intelligence and intellectual property together. Armando, some of your investments are in life science or medical research companies. How do you see AI working with medical research? I mean, it's already being done, but specific startups.
Yeah, so life sciences is about 25% of the investments we do, and the bulk of the other ones will be in cybersecurity or vertical industry applications or AI infrastructure. But life science in particular, there's two kinds of models. One of them is AI-driven drug discovery. And AI-driven drug discovery is really around taking a lot of physical data, either biological data or chemical data, and being able to look for patterns or new kinds of formulations that people haven't thought of.
But doesn't big pharma do this already?
Well, we humans are limited. We're limited by what we know. So if you think of it, most of the time, so if you have, so you're right. Let's say you have people who are PhDs. In order to get a PhD, you will know a lot about a certain topic. But by the fact that you spent 7 years learning about that topic, you didn't learn other topics next to it, right? It's just by definition, right? You're not no one is the PhD of everything. You're right. If you knew, this one thing. And so what happens many times is, yes, we know these things, but we also, by the fact that we know these things, we also know that these things will not work. And once we know that those things don't work, we have a bias is the wrong word, but we have a tendency not to try. We don't try things that we know don't work. And what AI drug discovery does is it tries things that we know don't work to see if they could work. And many times they do. And then the reason is because we're too tied on one vertical in one silo. And so, yes, so pharma can do this, but historically, startups move very fast. Startups can create new data sets very fast and then use the very new techniques to be able to generate new formulations. This has been done since the beginning of time. So pharma's model many times is, yes, they do a lot of in-house, but they also buy a lot of startups once the startups have those formulations tested and gone through FDA clearance. And then there's another model which has to do with behavior change for humans. And so we have done investments in things like nutrition and mental health. And what we found is that, at least on the clinical side, a lot of things around mental health are around behavior change or understanding humans. And the fact that humans go off the rails. We go off the rails in what we eat. We go off the rails and maybe in what we think or our emotions and things like that. And we used to think that AI was great because AI could be able to predict and prescribe. What we found is that humans, in order to change behavior of a human, the biggest behavior change is not that we don't know what to do. We all know we should not eat, like that big piece of cake followed with a Coca-Cola. But the problem is, how do you get back on the rails? And the human is the one that brings you back on the rails, that said, hey, it's okay. It's okay that we had something happen last night. Let's continue. The machines are not very good at that. We don't have empathy. AI for empathy is like decades away. So it's a human that brings you back. So the AI in those cases where you have human behavioral change is really is a back office kind of thing, which says, hey, this is a likely thing to happen. And then a human has to go in and then implement the change or try to bring the other human back onto the right path, no matter what the first human did. So in that case, that model for AI is really around analytics and prescription, but not directly to a human. It's to a care provider that will then work with the human.
Your mention of what is called negative know-how, or what doesn't work. I once wrote an article about negative know-how and how it's an overlooked value, but I think you're addressing how to mine it. Alex, we're getting towards the end of our time. I wanted to ask you about your experience with Indy Racing. You were a race engineer and you applied AI principles.
Yeah, and actually I could draw an analogy back to the drug discovery piece too, in that. So yeah, worked in INDYCAR racing almost 10 years, ran Andretti Autosport's vehicle dynamics and data science program, which supported a 4-car INDYCAR team. And the thing with INDYCARs, and it actually, I was going to add to what Armando was saying with drug discovery, is it's also a problem of permutations and combinatorics and almost an infinite number of potential solutions and combinations. So, for example, in IndyCar racing, not just the Indianapolis 500, which is the marquee race of the season, but there's actually usually like 18 races worldwide that take place, and they're all different track configurations. So for a given driver in a given track in a given conditions, maybe it's raining, maybe it's windy, maybe it's hot, maybe it's cold, all these different things, the goal of the engineers is to tune the race car to make the car go as fast as possible, essentially, which means win the race by getting to the finish line at the end of the race before anyone else does, right? And in these cars, you have like 80, 90 sensors. You're collecting every kind of data you can imagine: temperature, pressure, wind speed, distance to the ground, forces through the suspension, and so on. And you could tune so many things: spring rates, damper settings, wing angles, ride height, gear ratios, differential settings, and so on. So it becomes really an infinite combination of things that, as the engineer, any tweaks you make could either make the car faster or slower or more safe or more dangerous for the driver and more out of control and so on. And so how do you choose the best settings for the race car to go as fast as possible at a given track under a given set of conditions with a given driver? So it's similar to how you choose all the best molecules to put together and assemble the best drug, effective ingredient of a drug that has the biggest impact on some efficacy that then treats a condition, right? If you, in IndyCar racing, oftentimes in qualifying for a race, the difference between pole position, first place qualifying, and 15th place is hundredths of a second. So you're trying to squeeze the littlest last drop sometimes out of performance of the car with this infinite combination. Just like with the drug thing, if you can just barely improve one of these effective ingredient efficacy characteristics, that might save tens of thousands of lives. So that's really what we were working on, is you're just dealing with massive amounts of data. How do you make the most sense and insights out of the sensor data, the driver qualitative feedback, and turn that into actionable insights as quickly as possible in the race car setup. And then when the race is happening itself, you do the same thing with race strategy.
Historically, that person who could take all those variables and do it in real time is the genius. This was the person that we call the genius who has the insight. And that's what AI tries to bring to others, because there's not too many of those people who can take all of those 100,000 factors that Alex described and tell you, okay, this is what you need to do. And people talk about gut and we talk about feel. And that's what makes maybe the best driver compared to all of us, different, right? They can put them all together all at once. But, the AI is trying to get a machine to do that.
What one or two ideas or concepts would you like to leave listeners with?
I think the biggest thing is that AI is a set of math. And it's not only math, it's probabilistic math. So anything that it just gives you the probabilities of something happening, but it's really math-based, and all the models are really math-based. So it's not, so if there's anybody who's concerning, hey, there's like this thing is thinking, or it has conscience or something like that, I think we're years away from that.
Alex?
Yeah, I would just say learn about AI, learn how to write prompts, learn more about it, learn what you can do with it, whether for yourself or your organization. We are now in a world that is, we're seeing a lot more AI stuff, and it's going to keep going. It's not going backwards. The sort of train's left the station. And so I think it's really important for people to understand it as well as they can, not necessarily become an AI expert or a data scientist or machine learning engineer, but just understand it and start to figure out how you can use it in your daily lives and work.
Great. Well, thank you, gentlemen, very much. This was really a terrific discussion to help me understand much better how AI functions. And AI is just not generative AI. I think that's probably a very important lesson too. It may seem obvious to you two. I'll see you on March 28th in Evanston, both of you. I look forward to it.
Thank you so much.
Thank you. Good to see you both. Bye-bye.
Understanding IP Matters is brought to you by the Center for IP Understanding, an independent nonprofit. Follow CIPU on LinkedIn at the Center for Intellectual Property. Content conveyed is for informational purposes only and does not represent the views of CIPU or its affiliates. This episode was produced by Jack Shields for Wild Creek Studios.